Hey, you guys, I hope everyone is doing well. This is your test review. So you have a test on Wednesday. We've been starting to solve equations. We've been writing expressions. We've been starting to look at a few graphs. Hopefully you guys got the practice problems that I sent you. You've been able to print them and you are following along with me. That is the best way to use those practice problems. Go along with me, or even I'd love for you to try them on your own and then come back to the video and see if your answers are correct. All right, so let's get started. So the first question is, which inequality is true or is correct when x is equal to 6? So we plug in 6 for x, so 4 times 6. So 4 times 6 plus 1 is greater than or equal to 25. Well, 4 times 6 is 24, and 24 plus 1, is that greater than or equal to 25? Well, it's not greater than, but it is equal to. That is correct. Well, what about the second one? If we plug in 6 for x, we get same numbers. So 25 is greater, I wrote a 24. 25 is greater than 25. That is not true. They're equal, correct? So only the first inequality is correct. And the question is why? Why is it correct? Or why is the second one not correct? Because, and I would write, because 25 is equal to 25, not greater than. Or you could say something like, the first symbol means greater than or equal to. That would be a good statement as well. The first symbol means greater than or equal to. The second problem, Sally bought 5 pairs of pants that were on sale for $66.25. Each pair cost the same. Write an equation. Now remember, what's the difference in equations and expressions? Equations have equal signs. Write an equation to show the price of each pair of pants. Identify the variable. Solve the equation. All right, so we know how many pair of pants she bought, but we don't, yeah, we do. We know how many pairs of pants she bought, but we don't know how much the price of each one was. So I'm gonna let x equal the price of one pair of pants. So when it says identify your variable, I decided to use x. I could use anything I want. And I'm telling what it equals. What does it represent? Well, so if she bought 5 pairs of pants and they were X dollars each, she spent a total always means an equal sign, a total of $66.25. Well, that is my equation. I have my equal sign. That is an equation. And now in order to find the answer, I'm going to divide both sides of the equal sign by 5, because the opposite of multiplying by 5 is dividing by 5. So I'm just going to plug that right in my calculator. 5 divided by 5 is 1, and 1 times x is x. So I'm going to divide 66.25 by 5, and I found out that the pants are $13.25 each. So I've written an equation, I've identified the variable, I've solved the equation, and now it says for me to prove that my answer is correct. Well, since x is 13.25, I'm going to plug it back into my original equation. 5 times x, and x is 13.25, equals 66.25. I'm going to double check my answer on my calculator, and I'm going to say that 66.25 is equal to 66.25. And that is correct. So I just proved my answer is correct. The third one, in order to vote in Georgia, a person must be at least 18 years old. Write an inequality. And inequality just simply means we're using a greater than or less than sign, or greater than or equal to, or less than and equal to. Write an inequality to show the age of people that are allowed to vote. graph it and discuss the number line. So if X equals, represents the age of people that can vote, age of people that can vote, then I would say their age. Now, if you're at least 18, that means you're 18 years old or older. So X must be greater than or equal to 18. Since this is the age of people that can vote, the age of the people must be greater than or equal to 18 years old. Now, if I graph that, here's 0, here are my negative numbers down here. Here's my 18. So here would be about what, 10, I don't know, 9, and this would be about what, 27, something like that. Didn't have to be exact, but I'm going to fill in my circle because you can be 18 or you can be any age to the right of 18, okay? Now, let's say for 1 second, so we're going to pause for just a second from the problems that we see here. Let's say that this question ended up being about how much money I could spend. So if I said I had $30 and I wanted I had these king size candy bars and they were $5 each. I know, really big, right? So if I wanted $5 candy bars, I wanted to buy, how many could I buy and spend less than or equal to $30, okay? So if I have $30, I'm allowed to spend $30 or less. So I am buying candy. I wanna know how many total candy bars I could buy. Whoops, I was supposed to divide both sides by 5. I wrote an X. So my answer would be that I could buy 6 candy bars or less, right? So I could afford to buy 1 candy bar, 2 candy bars, 3 candy bars, 1 candy bar, no candy bars. And so I would circle, I would go where my 6 is. I'd fill in my dot because I could afford to buy 6 candy bars. That would be exactly $30 or less. Now, technically, inequalities go on forever in one direction. However, since these numbers represent the number of candy bars I could buy, and I got it down here into negative numbers, is there such a thing? Can I buy negative candy bars? Could I buy -1 candy bar, -2 candy bars? No. So my situation up here would make sense until I got to what, over what, 125? I don't think there's probably, you might know that a person's older than 125, but I don't know of any that's over 125. So my number line would make sense up until a certain age, right? I mean, it wouldn't make sense that my number line went to 200 because no one on earth is 200 years old. It wouldn't make sense for me to go past however the oldest person is in the state of Georgia. So let's say the oldest person is 110. Well, then my number line wouldn't make sense to go higher than that because people don't live that long. Same thing with number of candy bars I could buy. My number line makes sense between the numbers of 6 and 0 because I can buy that many candy bars, but I'm not allowed to buy negative candy bars. There's no such thing, right? So anyway, just think about that. If you ever have to graph an inequality and discuss it, you need to think about things like that. All right, Jordan runs 6 miles per hour. Write an equation to represent the scenario. That is a typo. That should not say equation. That should say expression. I will try to remember to change that before I send this to you, because the reason I know it can't be an equation is because I don't know the total number of miles he ran, okay? So now I'm allowed I can write an expression. I have enough information. So if, let's say H represents the number of hours. So what would my expression be? If Jordan runs 6 miles in 1 hour, he would run 12 miles in 2 hours, right? 18 miles in 3 hours. So how would I get those totals? I would just take H and I would multiply 6 by H. That's my expression. Now, if I did want to write an equation, so maybe this isn't a mistake. Maybe I want to write the word equation because maybe I want to say that y equals the total miles he runs. So I'm going to say this isn't a mistake. This is a good problem. I can say, because now I see that it wants an independent and dependent variable. So the number of hours, the total number of miles equals 6 times the number of hours. So which of these is my independent variable and which is my dependent variable? Well, if I made a T-chart, and let's say H would be the number of hours and Y would be the total miles. What if he ran for 0 hours? How many miles would he run? 0. What if he ran for 1 hour? He would run 6 miles. What if he ran for 2 hours? Well, how many miles would he run? 12. So guys, do you see that this total hours depends on number of hours? So my total number of miles is dependent on the number of hours. So H, I can run as long as I want to, right? I could run 1 hour, 2 hours. Well, I can't, I'm not a runner. But that means that H is my independent variable and Y is my dependent variable. Because my Y is the total number of miles, and that depends on how many hours I run. So when I want to describe the relationship, this is a great statement. I need some more room though. Let me go up here. Oh, nothing's erasing. All right, so what is my statement? And I'm gonna get rid of this because I like this question after all. My statement is the number of miles depends on the number of hours. That is describing the relationship as if you can read that. Just pretend you can. What it says is the number of miles depends on the number of hours. And that's my T-chart. Okay? All righty. Now let's look at number 1. It says what makes this equation true? So basically it's asking what if 4 is x? So if 4 is x, I would say 5 plus 3 times 4, is that 23? Well, 5 plus 12 is not 23. So 4 is out. All right, let's use 5. So what is 5 plus 3 times 5? Well, 3 times 5 is 15, and 15 plus 5 does not equal 23. So 5 is out. All right, let's look at the next one. So 4 and 5 are out. So let's look at 6. What if x were 6? Well, 6 times 3 is 18, and does 18 plus 23 equal, whoops, I wrote 25. Does 23 equal 23? Yes, that is going to be true. And if I plugged in a 7 in there, I would get 5 plus 21, which is not equal 23. So 6 is the only answer. Number 2, is this inequality true? So I'm going to multiply 6.5 times 2. I'm going to add that to 5.25 times 3. And I'm going to add 15.25 to that and see if that's greater than or equal to 45. So 6 times 2 is 13 plus 5.25 times 3 is 15.75 plus 15.25. Is that greater than or equal to 45? Well, I don't know. 15.25 plus 13. I got 44. Is 44 greater than or equal to 45? Is it greater than? No. Is it equal to? No. So the answer to this question is no, that is not true. All right, number 3. Let me erase all this stuff. Hopefully you guys got it. Like I said, I would love for you to, if you haven't already, pause the video, try the rest of these on your own, and then use this video just to make sure you're correct. All right, number 3, Shane had $50. He bought X number of candy bars for $2.50 each. Write an expression, expressions do not have equal signs, to show how much money he has left. So how much money does Shane have left? Well, we have to use how much Shane started with. And we see that he is buying candy. So is he adding to his money or is he subtracting from his money? Well, he's subtracting from his money. Well, it told me the X represents the number of candy bars he bought. Well, we don't know how much that is, but we do know that they're $2.50 each. So that would be my expression. $50 minus $2.50 times the number of candy bars. And that would be the total answer, and expressions do not need equal signs. And even if I wrote it like this, I'm subtracting $2.50 from a positive quantity of 50, that is equivalent. These are the same. So both of those are correct. Number 4, we want to solve for X. So what is on the side with X? On the side with X is plus 8. So how do I get rid of plus 8? I subtract 8. So X is equal to 9. And then how can I check my work? I would plug in 9 for X. Does 9 plus 8 equal 17? Yes, it does. Number 5, Rick, Mark, and Kevin worked a total of 18 hours at the golf course. Mark worked 6 hours and Rick worked 5 hours. How many hours did Kevin work? Write an equation and solve it. So we have 3 men or 3 guys. Mark worked 6 hours plus Rick worked 5 plus Kevin worked, I don't know, for a grand total of 18 hours. So there's an equation. I could combine these two like terms. 6 plus 5 is 11. So there's my equation. That's the best equation because it's simplified. And now to solve it, we want to get X by itself. Well, how do we cancel out a positive 11? The only way to cancel out a positive 11 is to subtract 11. So X would equal 7. So Kevin would work 7 hours. So I wrote my equation and I solved it. Number 6, this says 3 times X. So what's the opposite of multiplying by 3? I'm going to divide both sides of the equal sign by 3. 3 divided by 3 is 1. 1 times X is X. And 21 divided by 3 is 7. And number 7, how do you get rid of times 1/4? Well, I could divide by 1/4, and the same thing as dividing by 1/4 is to multiply 1/4 by its reciprocal. So what is the reciprocal of 1/4? We flip it. So 1/4 flipped is 4. Oh no. So I'm going to multiply both sides by 4/1 or just by 4 because 4/1 is 4. So these two fractions cancel. So X is equal to 7 times 4 is 28. And then I would go, okay, well, if X is 28, is 1/4 of 28, is that 7? Whoops, that's a 4. And then I would say, yep, I know I'm right. I see that I'm right. Number 8, the least X can be is 15. So how big can X be? It doesn't say, but it tells me the smallest number X is 15. The very smallest. Can it be 15? Yeah, the least it can be is 15. So what does that mean? X can be 15 or greater. X can be 15 or greater. So write an inequality to show this. So X can be greater than or equal to 15. If the least it can be is 15. That means it has to be 15 or bigger. So you got to kind of talk those out in your brain. Even with your mouth, you're at home, talk to yourself. It doesn't matter. All right, Jeff needs at least $76. So how much money does Jeff need? $76 or more. He already has $52. Which graph represents all the possible dollar amounts Jeff needs to save? All right, so Jeff has $52. plus he needs some more money to get at least 76. That means 76, the money Jeff needs, which is here, is got to be greater than or equal to 76, right? So first of all, we want to know if, since he already has $52, let's go ahead and subtract that amount and see how much more he needs to save. So 76 minus 52 is 24. So if he needs at least $76, that means he needs $24 or more than $24. So which one shows that if he saves $24 or more? Well, this one says he needs to save between $0 and $24, which doesn't make sense, right? This one says the same thing, basically, including 0 and 24. This one does not include 0 and 24. This one shows 24 or more. This one, the difference in this one is, and this one is that this doesn't include $24, but it says it could be equal to. So B is the best answer. B, or the second one, is the best answer. Number 10, which equation matches the table? So we have an X and Y chart. So let's plug in the X and Y's and see which is true for the whole table. All right, look at the first ordered pair. So X is 5, Y is 13. 5 and 13. All right, is that statement true? It is true. But don't just circle the answer and go, well, that one's got to be right. It's got to be right for the whole table, okay? Not just one. So we know the first one's right. Let's plug in the second X and Y value. The second X and Y value says 17 is equal to 7 plus 8. Does 7 plus 8 equal 17? No, it equals 15. That's not correct. So since it's not true for the whole table, we have to get rid of it. It doesn't work. All right, let's look at letter B. A number plus 10. So automatically when I think of 7 and 17, I know that 7 plus 10 equals 17. So this one works for letter B. 7 plus 10 equals 17, but does it work for all of them? Let's plug in the first values. If Y is 13 and X is 5, does 5 plus 10 equal 13? No, that's not right. So since it doesn't work for the whole table, we got to get rid of it. So there's only one choice left. So it's probably C, but let's just double check, okay? So we're going to plug in 13 for X and 5 for, or I said that wrong, 13 for Y and 5 for X. So 5 times 2 is 10, and does 10 plus 3 equal 13? That one's right. All right, let's try the third one. So 21 is our Y, 9 is our X, 9 times 2 is 18. Is 18 plus 3 21? Yep, that one works. And we'll just try one more just for triple checking. If Y is 29 and X is 13, I know that 13 times 2 is 26, and is 26 plus 3 equals 29? Yep, we are correct. So 13, or letter C, I should say, works for the whole table. Number 11, we have a graph, miles on a treadmill. Write an equation that shows the relationship between X and Y. So one thing that might help me is I can make a little T-chart, okay? So X, these are my values on the bottom. See, it's even labeled right there, but it's always going to be your values on the bottom, and the Y is always going to be this axis. So I'm not going to use 5 because I don't know exactly what my Y is, because this is not a whole number, right? But I do know when X is 0, Y is 0. This is the point 0, 0. What is this coordinate right here? What is our X? Our X is 10 and our Y is 1. 10, 1. What about this coordinate right there? Our X is 20 and our Y is 2. All right, what about this coordinate right here? 30 and Y is 3. Whoops, 30 and 3. And one more, we have 40 and 4. 40 and 4. So I didn't realize those were bigger numbers, but they are. But anyway, so basically, when you guys have this problem, your numbers are going to be smaller. So I didn't think about that. But I want to know, what can I do to X to get Y every time? Well, some of you are thinking that I'm going to divide X by 10, right? Isn't 10 divided by 10 1, and 20 divided by 10 is 2, and 30 divided by 10? So Y is equal to, so dividing by 10 is the same as multiplying 1/10 times X. So if X were 0, 0 times anything is 0, so that one works. If X is 10, if I multiply 1/10 times 10 over 1, I get 10 over 10, which is 1. That one's right. 1/10 of 20 is 20 divided by 10, which is 2, so that one's right. All right, so I didn't realize, when I picked that one real quick, I didn't think about it being a fraction, but I think you guys can handle it. You are super, super smart, wonderful children, young adults, whichever. All right, you guys, I hope that wasn't too much. Hopefully you feel prepared for your test. It's going to be a different kind of week. Thursday you are reviewing, and Friday you're doing a service learning project. So just 3 days of work this week. And this Zoom takes care of one of those days. So just your practice test and then your test on Wednesday. So I hope everyone has a great week. Next week, I hope you enjoy Thanksgiving with your family. I hope you take a few minutes to count your blessings. We all are very, very blessed. Keep yourselves healthy. And if you need me, let me know. See you later.